Okay, pre-cal students, in this video, we will be learning what certain changes to a given function do to the graph of the function, okay? In other words, we are going to take a function, an equation, and do some changes to it. Change some negative and positive signs, multiply it by a certain number, add or subtract numbers, and as we do that, we will then see what happens from one graph to another. So that's what we'll be doing today. Your heading for today is called Shifting, Stretching, and Reflecting Graphs, and that's what we're going to be doing today. We're going to be shifting them, moving them around, stretching them, and reflecting them, okay? The lesson number is 1.3, and be sure and include today's date, okay? Be sure and include today's date. Now, today's math is not really difficult to understand, but there is a lot of memorization, so please understand that. Now, please dedicate yourself to memorizing the things that I'm going to teach you so that you do well on your upcoming test. We really cannot begin to look at graphs being moved around until we have the foundations. I don't think I wanted the word foundation. Foundational graphs memorized. So let's go ahead and start there, okay? Please turn your books to page 92. On this page, you will see the 6 model graphs with their respective functions. Please memorize these graphs. Now, when I say that, right away you're going to be like, oh, Mr. Howard, that's crazy. Actually, most of these you already know, and the ones you don't know are really easy to come up with on your own. Okay, so let's take a look at each of these, and you take notes however you feel led to do so. Okay, so here we go. All right, if you're on page 92, you notice the first graph is called the constant function. Well, guys, we know that. Look, f of x is y. So if it's y equals 6, that means you have a vertical line going through the y-axis at where? 6. So that's pretty simple. We're going to go ahead and move on, okay? Really not a lot of memorization to do there. Your C would be 6, and f of x is y, and you know from algebra class that whenever y is all by itself in a function with no x, the graph is a horizontal line. Now, this one is really easy also. Watch this. F of x equals x is the same thing as y equals x. Well, guys, that means you have 1, 1 for a point, 2, 2 for a point, negative 1, negative 1, negative 2, negative 2, and then draw the line, okay? So really it's just simple. It's just 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, etc., etc. All of these are ordered pairs that lie on this graph, okay? And so that's a pretty easy function to memorize. Now, this one is also pretty easy, guys. Think about it. It's an absolute value function. Y equals the absolute value of x. So if you put 1 in, what do you get out? 1. But if you put negative 1 in, what do you get out? 1. Because the absolute value of negative 1 is 1. Now, I just thought of something if I'm going too fast. Remember, just have the supervising teacher pause the videos. If you put 2 in, you get out 2. If you put in negative 2 in, you still get out 2. So 1, 1, 2, 2, negative 1, 1, negative 2, 2. So even if you don't have these graphs memorized really well, you can quickly come up with 4 or 5 points, plot them, and sketch the graph as long as you know the basic shape of the graph, okay? It's really not that difficult, but please know this graph. Moving on, okay? This is called the square root graph, and again, this is pretty simple. Y equals the square root of x. You put a 0 in, you get out a 0. You put in a 1, the square root of 1 is 1. Put in a 4, the square root of 4 is 2. Put in a 9, the square root of 9 is 3. So 0, 0, 1, 1, 4, 2. And that's good enough right there. You kind of get the picture of the graph, okay? So, understand the square root graph is pretty simple. You need to know this graph, okay? This is the model graph. Alright, moving on. This is called a quadratic function. They call it a squaring function. That's fine. We call it a quadratic function. Y equals x squared. Now again, guys, this is pretty simple. Put a 1 in, get out a 1. Put a negative -1 in, and you get out a 1. Because -1 times -1 is 1. Put in a 2, and you get out a 4. Put in a -2, and you get out a 4. Look how easy that is. 1, 1, 2, 4. -1, 1, 2, 4. And then, of course, 0, 0. If you square 0, you get out 0. So there it is, guys. I mean, again, I want you to memorize these graphs, but really, if you'll just know the basic points to stick in real quick, you'll see the general pattern of the graph, okay? So you should be okay. All right, moving on. I think this is the last one. Yes. Okay, this is called the cubing function. That's kind of a weird name. This is an x cubed. Let me go ahead and make that. Well, actually, you can see this in your book, but it's f of x equals x cubed. Really, that's called a cubic function is what we call that. A cubic function. You should have learned that in Algebra 2. Remember, first degrees are called linear, second degrees are quadratic, third degrees are called cubic, fourth degrees are called quartic, Q-U-A-R-T-I-C, and then anything higher than that, we call it a fifth degree or a sixth degree function. So this function here is called a cubic function, or we can also call it a third degree function, okay? And once again, this is pretty easy, guys, to quickly throw some ordered pairs in. Put in 0, you get out 0. Put in a 1, you get out 1. Put in -1. -1 times -1 times -1 is -1. Put in a 2, you get out an 8. 2 times 2 times 2. Put in a -2, and you get out -8. So there we are. 0, 0. 1, 1, 2, 8 would be way up here somewhere. 1, -1, 2, -8 is way down here. And you definitely see, not sure why it's doing that, guys, hold on. And not sure why it's doing that, but anyways, you get the idea of the basic graph here, okay? So, you need to have these memorized. And then we're going to take these graphs and we're going to start shifting them, reflecting them, stretching them, shrinking them, etc. And so, that's what we're going to do today. So, please take some really good notes. I'm sure you're filled with great anticipation and excitement. So, here we go. Let's take a look at horizontal and vertical movements. That means moving the graphs from left to right and moving the graphs upward and downward, okay? Horizontal and vertical movements. Now, let's start off with this right here. You can take notes however you want to. If I go too fast, just pause the video, okay? Here's our quadratic function, okay? I told you to memorize this. There it is. Now, here's my main points. Let me get some red points up here. 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. Now, let me take some really good notes here, guys. Notice here the 6 is being added or subtracted directly to the x with the exponent on the outside, okay? The reason I know that the 6 is being subtracted directly to the x is because the exponent is on the outside, so it's first going to be subtracted from the x and then squared later. So whenever a number is added or subtracted directly to the x, please take some really good notes on this, guys. That is a horizontal movement. Please write that down. That is a horizontal movement. And you always move it the opposite of the sign. Please make note of that, okay? So, a number that's being added or subtracted directly to x is a horizontal movement, and you move the graph the opposite of the sign. So, we have a -6 that's being combined with the x directly to the x, so you would think you would move it to the left, 6. However, you move it the opposite of the sign, so we're going to move it 6 to the right. So all these points are going to go this way, 6. So 1, 2, 3, 4, 5, 6. Looks like I'm going to go off the graph a little bit. This one would be here, and this one would be about right there, okay? This one would be right here, and this one right here. So I'm probably not doing a perfect job, but I moved all of these points over 6, okay? Now, after I'm going to move these points. Look, here's a number being added or subtracted to the entire function at the end, not directly to the x. Do you see that? Right here, plus 3. That is a vertical movement or a vertical shift. And you do move it just the way the sign says. You don't move it the opposite way. So it's positive 3. So now these points are going to all move up 3 places. So 1, 2, 3. 1, 2, 3. I'm going to cross these off. Move this up. 1, 2, 3. Move this up. 1, 2, 3. Cross these off. And then move this point up. 1, 2, 3. Right here. Now students, this has not been the neatest presentation, so I hope I've not confused you. Let's go over this again. I took this point here and I moved it to the right. How many? 6. Then I moved it up. How many? 3. Okay, I did that to all the points. So my new graph is this right here. There we go. Guys, that's really pretty simple, okay? Let's try another one. You can work ahead or watch me. Okay, here is a square root function, okay? Now, we've taken the traditional standard square root function, and here's the graph. And also it's over here too. And we've subtracted 2 directly to the x. Now you might say, Mr. Earhart, how do you know that's directly to the x? Because if it wasn't, it would look like this. Square root of x, and then minus 2 on the end here. But because it's under the radical, that means you're first going to subtract 2 from the x before you take the square root of it, okay? So we just learned a second ago that when a number is added or subtracted directly to the x, that is a horizontal movement, and we move the opposite of the sign. So this graph is going to go positive 2 to the right. Now, let's get the main points up here. We know it's 0, 0, 1, 1, and 2, 4, 2. That's good enough. Let's take those 3 points and move them 2 to the right. So this will go 1, 2. This point will go 1, 2. This point here will go 1, 2. So there it is. So we picked up the black. And by the way, notice it doesn't continue downward, okay? The reason is you can never put a negative number in for the radical here, okay? So this is as far as it goes. It stops right here. So we simply move the graph 2 units to the right. Again, if I'm going too fast because you want to copy down the graphs or whatever, just pause the video. Have Mrs. Gallen or whoever the teacher is pause the video, okay? Alright, let's continue on. Now, absolute value. I'm going to change this problem. We've done all shifts to the right. We haven't done any to the left. So in your notes, make that a positive 4, okay? Alright, now this is your basic absolute value function, okay? Let's go ahead and get our points on this. 0, 0, put in a 1, you get a 1. Put in a 2, you get out a 2. 1, negative 1, 1, negative 2, 2. That's good enough. That's about 5 points. We can move around. Now if you'll look, we notice we've added a 4 directly to the x inside the absolute values. So that's going to be a shift. It's a positive 4. So you would think you'd go to the right, but you go the opposite direction. So we're going to go to the left 4 units. Then we have a negative 3 being added to the end here. That's not being added or subtracted directly to the x. That's going to be a negative 3 movement going down. So 4 to the left and 3 down. This point here, 1, 2, 3, 4. And then 1, 2, 3. So right here, okay? This point here, 1, 2, 3, 4. And then down, 1, 2, 3. Okay? This point here, over 4, 1, 2, 3, 4. And then down 3, 1, 2, 3. And of course, then the other point would end up being right here. And the other point would end up being right here. And so there's your absolute value graph. After it's been shifted 4 units to the left and 3 units down, okay? So the shifting part's pretty easy. Now the reflecting part is a little more difficult. The stretching and shrinking is pretty difficult, and we'll get to that in just a couple minutes here, okay? So now let's take a look at graphs. Excuse has the y and the x and y axis, okay? So here we go. Now, take some really good notes on this. You probably don't need to draw these graphs, although please feel free to if you want to. They're primarily there to help you see what I'm talking about when I tell you certain things, okay? So let's start off with this graph here. And definitely, again, I don't think you need to write down the actual pictures of the graph, but you'll definitely want to take notes as to what I'm saying. Now, here's my original graph in black, okay? Here it is. That's a quartic function, okay, a fourth degree. Now, you say, Mr. Earhart, this is not one of the graphs we had to memorize. I know, but notice I gave it to you right here, okay? And so that's still fine. We can work with this. Now, notice that I'm changing the sign here of the 150x. I'm making it a negative. Now notice I did not do it directly to the x. And you might say, well, Mr. Earhart, how would you do that directly to the x? Well, I'm glad you asked. It would look like this. 1/5 parentheses negative x, close your parentheses, and then put a 4, okay? So a negative sign is going to reflect the graph. It's either going to reflect it in the x-axis or it's going to reflect it in the y-axis, okay? Now, do you see this? This is when the negative sign is applied directly to the x. Do you see the difference between this and this? Here's my original problem. From here to here, the negative sign is applied directly to the x inside the parentheses with a fourth power on the outside, okay? From here to here, the negative sign is simply being put on the outside of the function with the number, okay? And so that's the difference between the two when I say one is being applied directly to the x and one is not, okay? So with that in mind, let's continue looking at the problem here where the negative sign is not being applied directly to the x. It is not. It is put right here. So anytime there's a negative sign applied to the entire function, not the x term, then it's going to cause the graph to be reflected in the x-axis. So this point here flips down here. 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 Okay, it totally flips around the x-axis. Okay? Please make note of that. Don't forget that. That is when the sign is not directly applied to the x. Now, let's take a look at another example. Obviously, you can imagine this example is going to be where the negative sign is applied directly to the x, okay? So here we go. Now, notice here's my original function. Now, notice, here's my first term. Notice we then put a negative inside the parentheses with the x with the 3 on the outside. Notice then we also put a negative here with this x inside the parentheses with the exponent 4 on the outside. And then of course plus 5 does not get affected. We're only applying the negative sign to the x's, okay? So when that happens, what you have is a reflection in the y-axis. A reflection in the y-axis. So students, what that means is simply this, okay? It just means that here's the original black graph. Now watch carefully. So it's going to be flipped over the y-axis. So this point here now became this point here. This point here became this point here. This point here became this point here. This black part of the graph here came over here. This black part here flipped over here. This black part here flipped over here. I think it's a little hard to see with the two graphs being on top of each other. This probably isn't the perfect example, but what you need to understand or write down or take notes on is the fact that whenever the negative sign is applied directly to all of the x's, it is going to be a reflection in the y-axis. A reflection in the y-axis. Let's practice a couple, okay? In your notes, I would like you to go ahead and copy down this function here. And then this function here, this is the change that we're going to make to it, okay? Now, having done that, go ahead and sketch the graph that looks something like this, okay? I'm giving you the graph, and you can just quickly sketch it. Doesn't have to be perfect. Just start here here, go up. Hit the origin, go down, and go up, okay? That's all you gotta do. Now, I'll pause a second while you do that. Okay, now, notice, I want you to go ahead and draw the graph that you would have if this change was made here. So we've multiplied a negative sign directly to the x. We've multiplied a negative sign directly to the x. So we just learned back here when that happens, it's a reflection in the y-axis. So this thing's going to be flipped around the y-axis. So this point here would go over to here. This point here, 1, 2, 3 and a half would be over here, 1, 2, 3 and a half. This point here, of course, would stay right here. This point here would come over to about here. Alright, let's see. This point here would come over to about right here. Okay, and that probably should about do it. It's good enough of an idea anyways. Gives a pretty good idea of what the graph would look like. Not the best, but hopefully you get the idea, okay? So it's been flipped around the y-axis, okay? Now, over here, notice we've multiplied a negative sign times each term, but not directly to the x. So this term was positive, it became negative. This term is negative, it became positive. Do you see that okay? When that happens, we learn back here, that's going to be a reflection in the x-axis. So this point here would be way down here. This point here would be about right here. This point here would stay right here. This point here would flip down to the x-axis here. This point here would be about right here. This point here is 1, 2, 3, 4, 5. 1, 2, 3, 4. About right here. This point would stay here. And this point here would be up here. 1, 2, 3, 4. 1, 2, 3, 4. And that gives us a pretty good idea. Alright. So I took some random points that are on this black graph and I moved them across the x-axis, okay? The same distance, like this point was way up here, so I went way down here for this point. This point was about here, so I went to about here, okay? So that's called reflecting the graph in the x-axis or in the y-axis, alright? Now let's go ahead and move on to our next problem. Finally, students, let's take a look at vertical and horizontal stretching and shrinking. This will be the most difficult, so please take really good notes and please pay attention. Okay, sorry. Okay, here we go. Now, let me shrink some of these so it's not so confusing, okay? Let me get rid of this here, if I can. Please take some really good notes, students, please, okay? This is horizontal stretching or shrinking. Now please watch what happens here, okay? Here's my beginning graph right here. There it is. Got it? That's my starting function. I said graph, sorry. That's my starting function. Now, notice I multiplied directly to the x, the number 2. 2 times x with a 3 on the outside. 2 times x inside the parentheses with the exponent of 1 on the outside. Okay? So, I took this function here and I multiplied it exactly by 2. Now, x's, you will have, please make note of this. Let me say that again. Whenever you multiply a number directly to the x's, you will have a horizontal stretch or shrink. Got it? Please make note of that. Now, how do you know which one? Well, I'm glad you asked. Here's how you know. If the number, I'm not sure why I put a 2, if the number is greater than or equal to -1 and less than or equal to 1, then it is going to be a stretch. Okay, it will be a stretch. So please make note of that. Okay, this is not the prettiest presentation, but write that down. Take some really good notes, okay? So let me say this again. If a number is multiplied directly to the x, it's going to be a horizontal stretch or shrink. If the number that's being multiplied is greater than -1 or and whatever less than 1, then it's going to be a stretch. Which that's kind of weird because all the numbers between 1 and -1 are like 1/2. And by the way, x could not equal 0. You really don't need to make note of that. That's common sense, guys. If x was 0 and you multiplied everything by 0, you'd have nothing left but y equals 0. Okay, so that just goes without saying. But anyways, it seems a little weird because all the numbers between 1 and -1 are 1/2, -1/2, 2/3. They're fractions, so you would think it would shrink, but that's not the case, okay? When you have a number that is between -1 and 1, it actually stretches it. Now, we're not going to break out our calculators and do some multiplying and prove all this, but trust me, it's true. Now, if the number is if the absolute value of the number is greater than 1, please make note of that. If the absolute value of the number is greater than 1, then you have a shrink. Okay, so if you put -5 in there, it's really 5 is greater than 1. It's a shrink. Okay, so if you multiply it by any number whose absolute value is greater than 1, it's going to be a shrink. Now, put a 2 in here real quick. Put a 2 in for x. Is the absolute value of 2 greater than 1? Yes, it is. Let's go over that again. What number did I multiply times this function here? 2. Is the absolute value of 2 greater than 1? Yes. So we have a shrink. And look, we do. It's a horizontal shrink. Here's the original black graph right here. And then when we multiplied it by 2, we got this horizontal shrink red graph. Okay, so there we go. Now it's real quick. And again, if you're copying down these graphs, you're welcome to. You might not really need to. The main thing you need to know is when you have a stretch or a horizontal stretch or shrink is when you've multiplied a number directly to the x. Then number 2, how do you know if it's a stretch or a shrink? Well, write down these models to use and you should be okay. Now, let me pull this down here real quick. Let me pull this one up just real quick. I'm not going to spend a lot of time on it. We're just about done with the notes here. But here, look at this, guys. On this example here, here's the original function. Then we multiply directly to the x. What number? 1/2 and 1/2. Okay, so since it was multiplied directly to the x, we know it's going to be a horizontal stretch or shrink. Now, how do we know that it's a stretch? Because look at the number 1/2. Doesn't 1/2 fit right in here? Sure it does. I mean, put it in here. Is the absolute value of 1/2 greater than 1? No. But doesn't 1/2 fit right here? Sure. 1/2 is greater than -1 and less than 1. So we have a stretch. And look, here it is. Here's the original black graph. And then when you multiply the original function by 1/2, it was a horizontal stretch. It stretched it out horizontally. Okay? And so there we go. Now, vertical real quick, and we'll be done. I'll wrap this up quickly, okay? Here we go. Let's take a look at vertical shrinking or stretching. And you know what's kind of funny? Everything's the complete opposite. So if you know one, then you know the other one. Because they're totally, completely the opposite. In fact, I might not even use these examples just to save time, to be honest with you, okay? that's not it. Okay, you're going to have a vertical stretch or shrink, students, when, now here it is, you multiply the function by a number, okay, not directly to the x, okay? So let me give you an example. Back to this example over here. Y equals 1/3 x cubed minus x. Okay, if you want an example, write this down, please. Okay, now if you have an original function like this, and then you multiply each term by, let's say, 1/2. Please notice I did not multiply the 1/2 directly to the x. If I would have, it would have looked like this. 1/2 x parentheses cubed minus parentheses 1/2 x parentheses. Okay, that's not what I have, okay? So here, when you multiply the function by a number times each term, but it's not directly to the x, it's just multiplied times the coefficient of each term. When that happens, you have a vertical stretch or stretch or shrink, okay? One of those two. Okay, let me go over that again. Please take some really good notes on this, guys. Whenever you multiply a number times each term, not directly to the x, okay, then it's going to be a vertical stretch or shrink. Now, that's the opposite, isn't it, what we just learned? And now, guess what else is the opposite? This right here, okay? If x is less than 1, greater than -1, guess what? You have a vertical shrink. And that's the opposite of what we just learned. For horizontal, this would have been a stretch. So please, please make note of this. Get very good notes and learn this. I mean, if you'll take good notes, write it down, memorize it, you'll be okay. I mean, I'm giving you everything you need to know here. You've just got to learn it, okay? So when it comes to horizontal stretches and shrinks, if the number's greater than -1, less than 1, it's a vertical stretch, a horizontal stretch. But when you're dealing with vertical stretches and shrinks, whenever the number is greater than -1, less than 1, it is a vertical shrink, okay? Now, you have a vertical stretch when the absolute value of x is greater than 1, okay? Greater than 1. Now, I think it would really be helpful if I tied all this up for you. I should have typed this up. So here we go. You ready? Let's do this. Horizontal. Horizontal. Vertical. Stretch. Shrink. This is a side-by-side comparison, okay? I should have typed this up, okay? When do you have a horizontal stretch or shrink? When a number is multiplied directly to x, okay? Alright, now, when that happens, it's horizontal. The number for a stretch is if it's the absolute value. Let's see, no, it'd be for a stretch, it would be x's greater than -1/2 and less than 1/2. No, it'd be 1, sorry. So -1 and +1 here, okay? So, for it to be a stretch, when you're dealing with horizontal stretches and shrinks, x has to be greater than -1 and less than 1. For it to be a shrink, alright, the number has to be, the absolute value of the number should be greater than 1. Now this will be the opposite over here. For a vertical stretch or shrink, you have a number just simply multiplied to each term, not directly to the x, okay? And the stretch, a vertical stretch, is going to be the absolute value of the numbers greater than 1, and the shrink will be x is greater than -1 and less than 1. Okay, I hope that helps, giving you a side-by-side comparison, okay? That's it for today. Hope the video's been a help. Stretching, shrinking, reflecting, shifting, graphs, and make sure you know this material.